This video just runs through the solution for question 12 on page 469 in book 4. It's a question on modular functions. So here's a copy of the diagram from that question. You can see that we've got three functions. In blue, we've got f of x. In green, we have h of x. And in red, we have g of x. And just for clarity, in these kind of questions, less than means below and greater than means above. So the first part of this question asks us where is f of x less than h of x, and our answers are always going to be in terms of the x values for those points of intersection where those graphs meet. And f of x is the blue function and h of x is the green function. So they're really asking us where is the blue function below the green function. So you can see that they meet at x equals minus 4 and they meet again at x equals 2. And f of x is below h of x between these two values. So my answer is going to be that x is between minus 4 and 2. Or to say it another way, between the x values of minus 4 and 2, the f of x function is below the h of x function. Next, they're asking me where is h of x below f of x. Now this is a little bit tricky to see in my graph because I kind of run out of space a little bit here to the left, but if you look at the book, it'll be a bit more clear. Once the blue function passes over the green function h of x, then h of x is going to be underneath f of x. So if I go out past that minus 4, I'm going to find that h of x is below f of x. So part of the solution for this is that x is less than minus 4. So when we go below minus 4 on the x value, the green function is below the blue function. And we can also see that it happens from this point on. So from this point on to the right, the green function is below the blue function. And that's from the value of 2 on the x-axis onwards. So the other part of the solution is x is greater than 2. So there's two areas, if you like, in the graph or in the diagram where the green function will be below the blue function. Okay, part 3 asks where is g of x less than f of x. So that's where is the red function below the blue function. Okay, so the red function is below the blue function from this point up as far as this point here. So again, we need to decide on the x values. Now, let's see. It starts here. That is around about 1.2, I would estimate. Again, estimate as accurately as you can from the graph yourself. If you're margin out, if you said maybe, for example, 1.25, then that's acceptable. There's going to be a leeway or a margin of error allowable in questions like this. So to the right of 1.2, and then they meet again here, and at this stage the red stops being below the blue, and that I would say is 3.5, so x is less than 3.5. And because this is just describing one region, I can kind of squish it together if I like and write it in this format. So in part 4 then they're asking me where is g of x less than h of x less than f of x. So I can break the statement up into two separate statements if I like. And you'll see that in both parts of the statement h of x exists. So really what's being said here is that I want h of x to be greater than g of x, and that's just me writing this first inequality from right to left as opposed to from left to right. And h of x has to be less than f of x, which is just straightforwardly the second part of the inequality written out. So what does this actually mean? Well, h of x has to be, which is the green function, has to be above g of x, so it has to be above the red function, and it has to be below the blue function. So it's between the red and the blue. So I can see that h of x is above g of x from this point to this point, but I also have the restriction that h of x has to be below f of x. So it has to be under the blue line. Well, for this portion, it's above the blue line, and for this portion, it's below the blue line. So I'm only really looking from here, from this point, over as far as this point. So let's just check the x values for those. So the x value for the first point of intersection is 2, and the x value for the second is 3. So it's from 2 up and from 3 down. So x is greater than 2 and x is less than 3. So x is between 2 and 3. Part 5 asks where is g of x less than f of x less than h of x. And so again, as long as both of the symbols are pointing to the left, as long as they're both less than symbols, it's really saying between. So where's f of x between g of x and h of x? So g of x is the red function and h of x is the green function. So I want to know where is f of x, the blue function, between the two of those. So where is it over the red function and under the green function? So I'll go to my diagram and look for that. So f of x is over the red function between these 2 points here. So for this stretch of blue, and it's under the green function h of x for just this part of it. So it's from this point up as far as this point that I want to focus on. So I have to decide now what x values are associated with that. So dropping down, I think we had said earlier that was about 1.2. So from 1.2 up as far as 2. So over 1.2 and under 2. So now part 6. Now the symbols are facing the other way this time. And if I like, I can split up my inequality in the same way that I did part 4. But you'll notice that effectively what's happening is that since the symbols are reversed compared to the previous two questions, the statement that I'm looking at is reversed as well. So in the example where I had two left-hand facing symbols, two less than symbols, it was over the first statement and under the second statement. Now I just reverse that. Now I want to be under the first statement and over the second statement. And you can see clearly why for the second one, h of x is greater than g of x. H of x is above g of x. And if you're reading it from h of x backwards, h of x is less than f of x. So it's underneath f of x. You might think that I'm saying that symbol incorrectly, but I'm not. I'm just reading from right to left instead of reading from left to right. And it matters the direction that I read the statement in when it comes to inequality. So since the narrower end of the symbol is closer to h of x is less than f of x. So h of x is the green function, f of x is the blue function, so I want the green function to be under the blue function. So the green function has to be under the blue function, so that's happening from this point on, but it has to be over the red function. So it's going to happen from this point as far as this point, at which point then the green function starts being below the red function again. Okay, so it's from 2 up as far as 3. So I'll say that x is between 2 and 3. And then finally part 7, f of x is greater than g of x is greater than h of x. Again, because the way the symbols are pointing, I'm going to be looking at g of x being under the first function and over the second function. So g of x is the red function, so I want it to be under the blue function. So that happens between this point and this point. So g of x is below f of x up as far as here. But I want it to be over h of x, and h of x is the green function. So that starts to happen when I get as far as this point here. So it's from 3 on and up as far as 3.5 roughly. With questions like part 4 up as far as part 7, it can be a struggle to remember which direction they want you to look at. So actually what can be useful is to make your decision, just look at the second part of the statement. So for example, you can see here in part 4, h of x is less than f of x. So they want h of x to be under f of x. And so, okay, that must mean it's over g of x. Same thing here, f of x is under because it's less than h of x. So they must mean it's over g of x. In part 6, we're looking at h of x being greater than g of x, so over g of x. That must mean they want it to be under f of x. And then the same in the last one. G of x has to be greater than h of x, so it's going to be over h of x. So then it must be the reverse for f of x. It must be under f of x.